Today we're going to talk about how to multiply a one-digit number by a three-digit number, or a three-digit number by a one-digit number, because we know that order of numbers in multiplication does not matter. 1 times 213 would be the same as 213. And we start with this problem because we know what the answer is. We know that 1 times 213 would be 213. But we're going to use it, something we know, to see why that works. So I'm going to represent 213 in my place value box. So I have 2 hundreds, 1 10, and 3 ones. So I'm going to multiply each number by 1. So if I have 2 hundreds times 1, I'm still going to have 2 hundreds. If I have 110 times 1, I'm going to have 110. If I have 3 ones times 1, I'm going to have 3 ones. So down here I can fill in 1 times 2 hundreds, 1 times 110, 1 times 3 ones. And I should get 213. Same thing with over here. I have 1 times 3, which is equal to 3. 1 times 10, which is equal to 10. And 1 times 200, which is equal to 200. And if I added up all of these partial products, 200 plus 10 plus 3 is 213. So now that we see that, let's look at it if we happen to do 213 times 2. Now, we could probably just add 213 plus 213 to get 426. But let's see what our place value chart, how that works. So again, I'm going to represent 213 by doing 2 hundreds, 1 10, and 3 ones. Now I'm going to multiply that by 2. So 2 hundreds times 2 gives me 4 hundreds. 1 times 2 gives me 2 tens. And 3 ones times 2 gives me 6 ones. So the answer should be 426. I can solve this by using a place value chart. I can also solve this by breaking apart the number. So if I have 213 times 2, I can break apart 213. 200 times 2, which is 400. 10 times 2, which is 20. And 3 times 2, which is 6. And I can add up all of those parts and get 426. Again, I'm breaking apart 213 by the place value. 200, 10, and 3. Because I need to multiply this whole number by 2. So I break apart the number into easier numbers to work with. We will be getting to the algorithm later on this week. Alright. Now let's try a different problem. 214 times 3. Again, I'm going to start with my place value chart just to see what that looks like. So I have 2 hundreds, 1 10, and 4 ones. I need to multiply that whole number by 3. So 2 hundreds times 3 gives me 6 hundreds. 1 10 times 3 gives me 3 tens. And 4 ones times 3 gives me 12 ones. But here I run into a problem. Since I have 12 ones I can make a group of 10 and a group of 2. And I know that 10 ones will give me an extra 10. So if I add 1 10 to my already 3 10s, I now have 4 10s. So my final answer is 600 4 10s and my leftover 2 ones that I didn't compose into another 10. So my answer is 642. What this looks like, if I do the partial product and I decompose the number, 214 times 3. Well, again, I'm going to break apart this number. That's 200 times 3, which now we can kind of do this in our head. 200 times 3 we know is 600. This 1 is in the tens place, so that's really 10 times 3. And we know 10 times 3 is 30. And finally, this is 4 ones, and I need to multiply that by 3. 4 times 3 is 12. Again, I add up these partial products to get an answer of 642. Again, if I'm going too fast, feel free to rewind or pause to catch up. Now let's go on to an even larger number. The thing here is, even though our number is larger, the process is still the same. So I'm going to take 1,245 and place it into my place value chart. 1,254, not 45. Now, I'm going to multiply each one of these by 3, because I'm multiplying this whole number by 3. So 1,000 times 3 gives me 3,000s. 200s times 3 gives me 600s. 5 10s times 3 gives me 15 10s. Now I know that 15 10s, I can decompose that, break it apart, into 10 plus 5. The reason I do that is because I know that 10 10s make 100. If I had 10 $10 bills, I would have the same as one $100 bill. So I will take those 10 10s and make another 100. Now I have 700s. Then I would do 4 ones times 3, which is 12. Same thing here. 12 is 10 plus 2. I know that 10 ones will make 1 10. So now I had 5 10s. I have 1 10. I know I'm kind of running out of room. Now that gives me 6 10s. And I only have 2 ones left over. So again, I had 3,000s, 700s, that 100 coming from these 10 10s, 6 10s, one of my 10s coming from these 10 ones, and 2 ones. So my answer should be 3,762. We're going to check that with the decomposition method, or partial product method. So 1,254 times 3. Now I could easily see if I got the right answer by adding this number 3 times. But we're working on multiplying. So I'm going to take this number and break it apart. This is 1,000 times 3, which is 3,000. This is 200 times 3, which is 600. This is 50 times 3. This one's a little challenging. But if I know 100 times 3 is 300, then 50 is half of 100, so that should be 150. Or I can think of it as 3 times 5, which is 15, times 10, which is 150. And then finally I have 4 times 3, which is 12. Then my goal is to add up all these numbers. So I know I'm kind of running out of room, so I'm going to put my answer to the side over here. So 2 plus 0 plus 0 plus 0 is 2. 5 plus 1 plus 0 plus 0 is 6. 0 plus 6 plus 1 is 7. And 3 plus nothing is 3. So 3,600, or 3,762. Again, we will get to the normal algorithm, the one that we are probably most familiar with. But right now, the purpose of this is to allow students to use numbers that they are very comfortable with. We have practiced multiplying by hundreds and tens and thousands, and we should know how to multiply single digits. Hopefully this video helps you. If you have any questions, please let me know.